Hi, everybody. So this is Miss Lorette again. So in this presentation, I'm going to be reviewing sections 2.1 and 2.2 with you. And what we cover in these two sections is solving 1 and 2-step equations. So you'll want a notebook so you can take notes, as well as a writing utensil. And then after you're done, your teacher may have various activities for you to complete, such as a Desmos, then maybe an exit ticket, and then possibly a worksheet for homework. So let's get into it. Okay, so when you're solving any equation, the goal is to always isolate the variable using inverse operations. So a helpful trick might be to draw an equal sign, or excuse me, a line down your equal sign like this. You don't have to do this, but it's a nice visual. And you're going to start by looking at the side that contains your variable and identify what operation we see. Whatever operation we see, we do the inverse of it to isolate the variable. So 14n, the number's touching the variable, that means multiplication. So I'm going to divide by 14 so that these cancel out. What I do to one side, I must do to the other to solve the equation. So if I divided the left side by 14, I have to divide the right side by 14. So the n is now going to be alone because we've canceled these 14s out. Let me fix that. That's better. I'm going to bring down my equal sign, and then I'm just going to divide. So I'm going to use my calculator to see what I get. So negative 126 divided by 14, I get negative 9. And there's my final answer. For the second equation, again, you can draw a line down your equal sign if that makes it easier, and then you start by looking at the side that contains your variable. I see n minus 8.9, so to get rid of that minus, I do the inverse of subtracting. The inverse of subtracting is to add, and what I do to one side, I do to the other. And now I'll just use a calculator to get my answer. So 6.592 plus 8.9, I get 15.492. I'm going to bring down my equal sign, and I'm going to bring down my variable, which is now alone because these two values canceled because they were opposites. So just a few things to note before we keep going on. So notice how when I do this, I'm showing all of my work. You always want to do that. And when I write my final answer, I'm not just writing the number by itself. I'm writing the variable equals a number. Your final answer should still be an equation. Okay, let's look at the last one. I'm going to draw a line down my equal sign. That's a little crooked. Let me try again. And I see negative 5/7 plus a equals 178 over 35. So I want to get rid of this 5/7. So it's a little bit confusing for some students because we see a minus and we see a plus. So this plus actually is attached to the variable a. So whenever you're trying to determine the sign of a value, look just to the left of it. So the plus sign is just to the left of the a. All that's telling me is that my variable is positive. So really, in order to determine the inverse operation to isolate here, I need to look just to the left of the fraction. It's a negative, which is like subtraction, so the opposite of that is going to be to add 5/7. We're not going to subtract it, we're going to add it to both sides. Now, you could use a calculator to get your answer, depending on what type of calculator you're using. If you're doing it without a calculator, here's how you're going to actually add and subtract the fractions together. In order to add and subtract fractions, we need to make sure they have a common denominator. So I have a denominator of 35 and a denominator of 7. I want to pick the smallest number that both of those can create through multiplication. Well, the smallest number they can both create is 35. I can make the 7 a 35 by simply multiplying the top and the bottom by 5. So when you do this, when you manipulate a fraction in this way, Whatever you do to the bottom, you have to do to the top. So I'm actually going to rewrite this. This is now 178 over 35 plus 5 times 5 gives me 25. My denominator should be the same, should be 35. And I get, when I do the numerators in my calculator, 178 plus 25 gives me 203 over 35. And then if you're using a scientific calculator, your calculator should be able to reduce it for you. Otherwise, you can reduce both of these numbers by 7, and you should get n equals 29 over 5. In math, including showing all the work being a requirement, you always want to simplify fractions completely. Okay, if you don't show the work, it's not complete. If you don't simplify fractions, it's not complete. So make sure to do both of those things. Okay, let's take a look at this example here. I'm just going to erase my board. Before we can talk about problems like this, we need to define a key term here, okay? That term is reciprocal. Reciprocal does not mean opposite. Those two terms in math have two different meanings. Opposite means you're changing the sign. So if it's positive, the opposite would be negative, and vice versa. Reciprocal is the multiplicative, meaning you're multiplying, inverse of a number. Inverse meaning if you did an operation with two inverses, they would undo each other. They would cancel out. Another way to think of this is it's like flipping a number upside down. Okay, so for example, if you wanted to find the reciprocal of 1 divided by 2, you would flip those numbers upside down and you would get 2 divided by 1. If you were dealing with, say, actually, let me write down these examples. So 1 divided by 2, it's a little weird. I'm trying to draw a little curly Q arrow. There we go. That would become 2 divided by 1. If you had a -5, though, let's say, and you were dealing with an integer, to find its reciprocal, make it look like a fraction by putting it over 1 first and then flipping those numbers upside down. So it would become 1 divided by -5. Notice how both of these things stay negatives here. Reciprocal, you're not changing the sign. You're just changing the locations of the numbers. So when I look at an equation like this, whoops, still getting used to this tablet. I see -3/7 x. Because there's no symbol in between, it's being multiplied. So we know that the inverse of multiplying is to divide. But if you divide by a fraction, you might recall that we have to do keep, change, flip. The shortcut to solving equations like this, when you have a fraction times a variable, is just multiply both sides by the reciprocal of that fraction. And again, what I do to one side, I must do to the other. And what's going to happen here is that the two negatives on the left are going to cancel. The two 7s are going to cross cancel. And the 3s are going to cross cancel. So a number and its reciprocal, when we multiply them together, should leave us with 1. So in other words, I'm left with 1x or just x. I bring down my equal sign, and then you can use a calculator to do this, or you can do it mentally. I have a negative times a negative, so I know those are going to cancel, and I'm going to have a positive answer down here. And then it's helpful to look for things that cross cancel. When you're looking for things to cross cancel, you're looking for things on the top and bottom. So does the 1 cross cancel with the 28 or the 3? Or does the 7 cross cancel with the 3 or the 28? Well, the only thing that's going to cross cancel here is the 7 and the 28. To cross cancel, you simply divide both numbers by the largest value that goes evenly into both. In this case, it would be 7. I can divide 7 by 7 and get 1. I can divide 28 by 7 and get 4. Now, to multiply fractions, we don't need a common denominator. You just multiply the tops and the bottoms. 1 times 1 gives me 1. 4 times 3 gives me 12. And again, I leave it positive because the two negatives canceled. Okay, so take a moment to pause the video and copy this table in your notes. When we have two-step equations, there's two things that we got to consider, two scenarios. Okay, so the question you should be asking yourself when you're looking at a two-step equation is, do we see a giant fraction? What I mean by that is something that looks like this. So above the yes box, I'm going to put an example of what that looks like. Let's say we had x plus 3, and this entire sum was all over 2, and this equaled 5. So that's what I mean by a giant fraction. You see how in this fraction, there's an entire expression in the numerator? That's my simple way of saying that. It's a giant fraction. If the answer is no, it's not a giant fraction, it would look something like this. Okay, so here I'm using the same exact values, but instead of the x plus 3 both being together, they're separated. Okay, so the only fraction I see here, the only part that has division, only has a very simple numerator, and then the plus or minus piece is separate from that. So depending on how your equation looks will determine how you solve it. If it looks like the equation on the left, you're going to follow these steps. You're going to multiply both sides by the denominator first of that giant fraction to clear the giant fraction. And then what you'll be left with is what was in the numerator. So then you'll undo addition and subtraction. If it looks like this on the right-hand side, you're going to undo the addition and subtraction first and undo the multiplication and division last. Another way to think of the no scenario is you take care of the number that's not touching the variable first and then handle what is. So let's do a few examples. Okay, so I'm going to walk you through 3 of these. So again, I'm going to put a line down my equal sign just because visually that might be helpful. So the first thing I want to ask myself is, do I see any giant fractions here? It should be obvious for the first one. No, I don't see any division bars at all. So I can just solve a two-step equation by following that same set of steps where it said no. Undo the addition or subtraction first. So I'm going to do that by subtracting the 7. These will cancel. What I do to one side, I must do to the other. 27 minus 7 gives me 20. I bring down my equal sign, and I bring down my minus 4a in my next line of work. And this is also, again, the amount of work that you would want to show on a homework assignment or a test or a quiz, anything that you're presenting to your teacher for credit. And then the last thing, now it's a one step. Now I know that since this number is touching, it's multiplication, so I'm just going to divide. I'm going to divide both sides by -4 so that these -4s will completely cancel out on the right. I bring down my variable, I bring down my equals, and then my quotient should give me a -5. Here's my final answer. Let's take a look at the next one. Okay, so I do see division here. I see a fraction bar. So I should be asking myself, is it a giant fraction or is it just a typical two-step? So this was just a typical two-step where it's not a giant fraction. And I know that because when I look at this numerator here, it's just the variable by itself. There's nothing crazy going on in this numerator, okay? So when I look back at that table in my notes where it said no, I'm gonna undo addition, subtraction first again. So I have subtraction, the opposite is to add. I'll do it to both sides. These will cancel. I bring down my k divided by 2. I bring down my equals. And on the right-hand side, if you added these two numbers together, you should have gotten -5. Now it's a one-step. I see division. The opposite is to multiply. So I'm going to multiply both sides by 2. They'll cancel out on the left, leaving me with k. And I get -10 as my product on the right. Here's my final answer. My variable is now alone. And last but not least, the third example. So in the third example, when I look at this, I see a division bar. So I'm asking myself, is it a giant fraction? It is in this case because the numerator has plus or minus sitting on top of it. So this is a much more complicated looking fraction than for the second one. So my first step here, you should be looking at the yes section of that table, will be to multiply both sides by the denominator of this fraction, okay? So when we do this, what's gonna happen is this 3 is really a numerator value. Let me actually show you that in a different color. I'm not multiplying 3 by 3. I'm multiplying this entire expression by 3 over 1. So what ends up happening is that this 3 is in the denominator, this 3 is in the numerator. They cross-cancel with each other, okay? So all I'm left with, I'm going to bring down my equals, is everything that was in the numerator, just 2 plus k. That denominator goes away. But again, what we did on one side, I must do to the other. My product here, when I multiply, should just give me -6. And now it's a one step. I have a +2 that I want to get rid of for the addition subtraction step. To get rid of a positive, I subtract it from both sides. -6 minus 2. This is really same sign, so I'm actually adding two negatives together. I should get -8 as my answer. Okay. And I believe that was the last slide. So hopefully you found this review helpful to guide you so that way you can complete any other activities that your teacher may have. Of course, reach out to your math teacher if you have any questions or consider rewatching this video for clarification. I'll see you guys next time. Bye.